In this orthokeratology case, what we want to do is make some quadrant-specific changes to the back of the lens. If we look at the quad display here in the top right, we can see that there's this aqua or lighter colored blue arc down here, and that just indicates that the curve in this area is a little bit steeper. And if we go to that area, you can actually get a quantitative value for that curve. So we're in the high 30s to low 40s, whereas on the opposite side, this is the superior aspect of the lens. Now we're in the low 30s. So we've got close to a 10 diopter variation between um, the curves, superior versus inferior. And the suspicion is that this is causing excessive lens vault down here, and so we want to relieve that a little bit. So the way to do that is go into 50% mode. So in a freeform lens, 50% mode will change the bottom meridian as well as the neighboring meridians. And what we want to do first is see where our sag is. We're at 1916, so about 100 microns, or I guess 90 microns taller than the superior part of the lens. And so I would go ahead and relieve this probably 40 to 50 microns and get a little bit more symmetry there. So if we say a target of 45, then we're going to end up at 1871. So when 50%, we'll go into the 8x to speed things up. And we're going to click up to decrease sag. As we do this, the new curve you'll see will start to blend in with the other areas of the lens. It's not more steep than the other areas. As we're getting more uniform in the curve and sag, you'll see that the graphic becomes a little more uniform as well. So let's see where we are right now. 1874, pretty close. Just a couple more clicks here. And 1871. So with this reduction of sagittal height or depth out at the periphery of the lens, everything anterior or central to that should be able to set onto the cornea a little bit sooner, a little bit more evenly around the lens. One other thing I noticed with this lens is we have an overfraction in here, and what this does is it changes the power on the front surface of the lens, but it does not change anything on the back surface of the lens. I don't think this patient will end up being undercorrected, but for example, if you wanted to adjust the base curve of this lens by, let's say, the 1.25 diopters, what you don't want to do is put the value in here, because this will not change anything on the back surface of the lens. This only changes the front surface of the lens, changes the optics of the lens as the patient looks through it. If we want to change the base curve, what we want to do is make those changes here at the red control point. And for example, right now we're at a power of minus 0.14. If we click up, this will flatten the base curve, and you will see the power of the lens change proportionally to the amount you're changing the base curve. So the way software does is it changes the lens power for you as you change the base curve. So if you flatten the base curve by 1 diopter, then the wave will make the lens power 1 diopter more plus. If you manually change the lens power here, that will change the optics of the lens, but it does not change anything on the back surface of the lens. And that's usually where we're more interested in making changes with regard to orthokeratology. You do have the prism box checked, and I recommend leaving that checked. This is a freeform lens, and we want to encourage this lens as much as we can to orient to a very specific axis, and adding prism there can help. I would also ask the lab to dot the lens at the prism location, so that when you inspect the lens or examine the patient, you can see how it is orienting on the eye.